the next question is pH of barium hydroxide is 12. Hence Ksp of barium hydroxide is option A 5 into 10 to the power minus 7, option B 5 into 10 to the power minus 4, option C 4 into 10 to the power minus 6, and option D 1 into 10 to the power minus 6. So in this problem we need to calculate the Ksp for barium hydroxide. So for barium hydroxide Ksp is equal to, so barium hydroxide dissociates to give barium ion and 2 OH minus ion. Hence Ksp is given by the formula Ksp, that is solubility product, is equal to concentration of barium ion into concentration of OH minus ion raised to 2. To calculate the Ksp value, we require the concentration of barium ion as well as the concentration of OH minus ion. But they have given us the pH of barium hydroxide. So pH of barium hydroxide is equal to 12. From the pH, you cannot calculate the OH minus ion concentration. We know that pH plus pOH is equal to 14. So if pH plus pOH is equal to 14, then pOH will be equal to 2. If pOH is equal to 2, then the OH minus ion concentration will be equal to 10 to the power minus 2. From this you can obtain the concentration of OH minus ion, which is equal to 10 to the power minus 2. If I write the equation, that is barium hydroxide in equilibrium with barium 2 plus ion plus 2 OH minus ion. If the concentration of hydroxyl ion is 10 to the power minus 2, then the barium ion will be 10 to the power minus 2 divided by 2. Why? Because if 2 OH minus are present, then the barium ion will be 1. So therefore, if 10 to the power minus 2 is present, then the concentration of barium ion will be half of that, it will be equal to 10 to the power minus 2. So hence Ksp is equal to concentration of barium ion, that is 10 to the power minus 2 divided by 2, hydroxyl ion, that is 10 to the power minus 2 raised to 2. Now, so 10 to the power minus 2, that is 1 by 2, that is 0.5 into 10 to the power minus 2 into 10 to the power minus 4 square. So that is 0.5 into 10 to the power minus 6, that is nothing but 5 into, if I shift a point forward, I should multiply it by 10 to the power 1, so it becomes 10 to the power minus 7. Hence option A is the right answer. So students, the next question is formic acid and acetic acid solutions have equal pH. If K1 by K2, that is the ratio of acid ionization constant is 4, their molar concentration ratio will be. Let us solve this problem. pH are equal means, that is H plus ion concentration of one acid should be equal to the H plus ion concentration of the second acid, because if pH are same, then the concentration of H plus ion should be same. Then concentration of H plus ion is given by the formula root of Ka into C, that is K1 into C1, that will be equal to root of K2 into C2, where K1 is the ionization constant of acid 1 and K2 is the ionization constant of acid 2, C1 is the concentration of acid 1 and C2 is the concentration of acid 2. Squaring it, you get K1 C1 is equal to K2 C2. We require the molar concentration ratios, that is C1 by C2. C1 by C2 is equal to K2 by K1. But they have given us K1 by K2 ratio as 4. So I can write this as 1 divided by K1 by K2. That is 1 divided by K1 by K2 is 4. That is 1 by 4. That is nothing but 0.25. Hence option D is the right answer. The next question is the molarity of magnesium ions in saturated solution of magnesium phosphate whose solubility product is 1.08 into 10 to the power minus 13. Your options are option A 1 into 10 to the power minus 3, option B 3 into 10 to the power minus 3, option C 2 into 10 to the power minus 3, option D 4 into 10 to the power minus 3. The solution is now magnesium phosphate on dissociation gives 3 magnesium ion and 2 phosphate ions. That is, if the solubility of magnesium phosphate is S, then the concentration of magnesium ion will be 3S and the concentration of phosphate ions will be 2S. So once we calculate the solubility of magnesium phosphate, we can calculate the concentration of magnesium ions, because the magnesium ions produced in the solution will be 3 times the solubility of magnesium phosphate. Since they have given us the solubility product, from the solubility product you can easily calculate the solubility of magnesium phosphate. Now, since it is of the type A3B2, so solubility product KSP is equal to general formula x raised to x, y raised to y, s raised to x plus y. Here why we are calculating the solubility? Because they have given us the solubility product and they have asked us to calculate the concentration. So from the solubility product you can calculate the solubility of magnesium phosphate, and the concentration of magnesium ions will be 3 times its solubility, because 1 magnesium phosphate will give you 3 magnesium ions. That will be equal to, so 3 raised to 3, 2 raised to 2, s raised to 3 plus 2, that will be 3 into 3, 3 into 3 into 3 is 27, into 4 that is 108 s raised to 5, or s is equal to fifth root of KSP divided by 108. So s is equal to fifth root of KSP value given is 1.08 into 10 to the power minus 13 divided by 108. That is fifth root of, I will shift the point, so 108, if I shift the point after 2 digits I should multiply it by 10 to the power minus 2, hence it becomes 10 to the power minus 15 divided by 108. 10 gets cancelled, so fifth root of 10 to the power minus 15 is 10 to the power minus 3. This is 10 to the power minus 3 mole per liter is the solubility of magnesium phosphate. But we require the concentration of magnesium ions. The concentration of magnesium ions will be equal to 3 times its solubility, that is equal to 3 into 10 to the power minus 3. Hence option B is the right answer.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.